I'm going to go really quickly through these because I do have a lot of slides. I have about 40, so it's about less than 30 seconds per slide. This my talk is sort of stirred up by one of these IDC conversations, which is that mailing list that we were all asked to get onto, and basically the question that somebody proposed, I think it was Usman, but maybe it was someone else. But why aren't architects participating in the imaginings of the future? And I think specifically with respect to computation, and also specifically because architecture deals with the predictive, just usually in shorter life cycles. A few reasons popped up, not mine, but from other people. One is this fetish with forms that seems to have been going on now for about 15 years. And second is kind of this unpredictability of new behaviors related to new technologies. And I'll come back to that as well. And I started thinking about this too because it is a little frustrating. My answer was really that it has to do with the economics of R&D. Architects don't invent very often, basically I think because it's very expensive to invent. We're the end user, and we're really, I think, the last in line with respect to a lot of technologies. We usurp, and at best, I think when we invent, we appreciate and marshal different technologies that exist, and then we try and make those suit our architectural vision, whatever that may be. So what does R&D have to do with being visionary? I only read hard sci-fi, basically looking at what exists, extrapolating existing technologies off into the future. I'm also a practicing architect, which is hugely influential in, I think, all of my thinking. I try and make a living through practicing architecture. And clients typically don't like to pay for inventions. Envisioning the future becomes very pragmatic. When we get outside of the circle of like the people who are gathered here, it gets very difficult to invent. And I think this practical, pragmatic approach to me is, it keeps me very well grounded. But systems invented by others, not architects, don't necessarily deal with architectural issues of space. These are some problems, I think, that exist. And a lot of research initiatives aren't being led by architects dealing with smart or responsive or interactive architecture. It's really kind of research in a bubble in that there's also no client involvement. Personally, I'm from a kinetic background, which is kind of a different approach that to come at this area. I actually first met Omar to kind of say how long I've been involved in this. Omar was a student of mine at MIT about, I think, almost 10 years ago in a course, Intelligent Kinetic Systems, that I was teaching. And my approach was really that if something can move, then it really ought to have a means of telling it how and when to move or respond or behave. As opposed to typically now you would come at this where if we have all of this information that understands who we are, where we are, what we desire, then we ought to have a space that can actively facilitate this. Architecture can't really afford the research of mass production that we find in automotive, industrial design, and products. I think when smart homes are mass produced, they need to be economically feasible. And this is kind of that pragmatism coming in again. And this technology is always borrowed. There are some large initiatives like KB Homes that are integrating these smart homes, et cetera. But it's not architects who are doing this. Architecture research doesn't really have the funding of military or geriatrics or disabled. And this happens outside of architecture. Then architects grab it and try to create this future. There's also some great new originators, I think, these days in terms of artistic explorations and academic initiatives, and also the new kind of commercial trend of home automation. I'll just skip that. But I've done, this is kind of relevant, but I've done a bit of research with like Boeing and Herman Miller, and these are corporations outside of architecture, bringing in architects, and I think basically to understand systems within a whole and also to understand behaviors. So I said I would come back to sort of the fetishes of form. Now I think it's relevant because we do now have architects as consultants in this area to other architects. There's Geary Technologies, there's RED. There's actually quite a number of these offices who are architects who understand the technologies that exist and help other architects invent. But I think the key here is not that they're architects understanding technologies, but that these are architects understanding that the tools can be invented and that they can be malleable to idiosyncratic designer needs. So I think this is actually a really good thing that's happening. And to the second one, this unpredictability of new behaviors related to new technologies. I kind of break it down into two different types of needs. We have pragmatic types of things, and then humanistic types of needs. Pragmatic is dealing with adaptability and optimization, and the humanistic, sociology and psychology. With the pragmatic, it's pretty easy. Things like safety, security, spatial efficiency, all of these types of things. This is basically looking at how a space or object is doing something and how it can do it better. It's, like I said, it's pretty easy because a lot of these applications, they make economic sense. They work for Geron technology. They work for disabled, the private interest, and sustainability, all of this. Now, the humanistic is, I think, a little more difficult. It's dealing with things like human behaviors and sensing of place and understanding of space, control of space, attachment, and how we bond to space. It's much harder because we can't very well predict these new behaviors that are altered by our new technologies. There used to be a quote that I always used. I try not to now, but if an environment would adapt to our desires, it would shape our experience. I don't really agree with that anymore. If we're not visionary with respect to behaviors, we're going to design specifications that demand new modes of behaviors. And we can kind of argue this next point later, but intuition, in my opinion, is nothing but learned experience. Our behaviors are intuitive. And I think architects, not the citizens, not the computer science, ought to really play a stronger role in directing this development. Architects need to understand human interactions with the built environment enough to be predictive, but that's kind of a difficult word too, but I think be predictive enough in order to facilitate these conversations, enough to design spaces that can adapt and that can foster human interactions, but not to demand new behaviors. So I think in the same way that we have architects understanding malleable, idiosyncratic tool making in terms of form making, we need to make designers that look at tools in the same way with respect to designing these types of systems. 5 minutes. I think I'm okay. And this really comes at looking at a pedagogical approach, which like I said, I've been with my practice for about 80% and academia for about 20%. But what I've been teaching at a lot of different schools, at SCI-Arc and at Art Center and at MIT and in Hong Kong, and at Cal Poly, and all these places, it's kind of the same. I don't know, almost like a preacher, grounding this in and kind of developing this pedagogical approach that really allows students to kind of look at new modes of designing that they can understand these tools as malleable, sort of idiosyncratic things, and you develop new types of heuristics. It takes in a number of things like virtual modeling, of course, simulation and visualization, both I think equally important. Physical modeling, where you're actually looking at mechanical things and CNC fabrication and different types of robotics, and actually prototyping. And I think this prototyping aspect is really key so that you can make things full scale, understand how people interact with them. And we always have these kind of post-user occupancy style of analysis of these environments. And a few of these, one other thing is that we also deal with sort of new conceptual issues of human and environmental interaction that typically architects aren't even kind of dealing with these issues, like I said, is kind of problematic when you're dealing with unpredictable types of behaviors. And so here's a few of those types of environments. This one at SCIARC is basically it's called iZoo, but the idea was that how does the environment teach us how to use it? And you know, there's a lot of intuitions that we have everywhere in how we use our spaces. Everything from opening a window to opening a door to using a hand dryer in the bathroom. And so everything within this space is sort of networked and interactive, but more importantly, there's nothing that you would expect. And you have to learn how to open up the door to get in through the space. The space, you have to learn how to do everything within this environment. And that was just one of the spaces. Another one was kind of dealing with pragmatic idea of space and how, let me see, another one here is sort of a spa and how you can navigate throughout this space as well. But the point here is just that these are full-scale projects that you can wander around, you can interact with, and the students are prototyping these at full scale and then looking at how people behave within them and understanding what to change, understanding how we actually interact with these types of things. And so it's part of students like learning to actually construct at full scale in terms of prototyping, because when you're trying to understand new behaviors, you really have to prototype these things and get this types of feedback. So and the last thing, I just want to show this project that we just did in LA, which is still up for like 6 months. And it's just this large scale kind of pneumatic environment that's completely interactive with all of these large balloons. And basically the entire system is at a static state of rest until people come into it. And once they come into it, then you would hit one of these balloons, which causes essentially a chain reaction, and all of the balloons will, like one balloon will deflate, and they're hooked up, you know, into a system where each pair of balloons is connected to each other. So one balloon will deflate when you bump into it, inflating another balloon at another location, which will bump into another balloon, causing that to deflate. And essentially you become kind of this virus when you walk into this space, and after people leave it alone for a certain period of time, it comes back to a state of rest. And it's pretty interesting when there's actually just a few people in there, 3 or 4, because you can really kind of see how you're throwing this system into a chaotic state. So last slide, in terms of profiles of future, there's a ton of issues, I think, that are kind of on the forefront, and like smart materials, I think, are extremely interesting, in nanotechnologies and bioinformatics and autonomous self-maintenance types of robots. All of these types of things are kind of just even still being discovered, where in terms of these mechanical robotic things, I think are already starting to look extremely kind of old-fashioned and kind of 19th century. And so there is a lot of to discover, and I think future architects really just need to understand that tools are malleable and to develop new types of heuristics with essentially the goal of communication, so that we're not being experts, but we're understanding how to communicate design intent with respect to behaviors and how we're using these types of places. I think that's it. Yep. Okay, thank you.